Hey guys, and welcome back. In this video, we'll be covering about NumPy data structure. So let's get started. So what is NumPy? Well, going to their main webpage, link down here. Basically, NumPy is the fundamental package for scientific computing with Python. So this package is specific for Python to use. And it does contain a lot of things like a powerful n-dimensional array object, sophisticated functions, a lot of tools for integrating other language code in here, and useful linear algebra, some transformations, and other random number capabilities. So all of these are very essential for data processing and analysis. So hopefully this will become very useful for your whatever data you have to handle later on. So often it's pronounced NumPy, but I sometimes call it NumPy. So whichever you prefer, they're both fine and referring to this particular package. All right, so as mentioned in the previous slide, one of the advantage of using NumPy is its array structure. So this array structure is quite different to Python's list. It does have some constraints, but it provides us with much more powerful usage. So we're going to cover all of those in this video. Well, not all of it, but the useful ones. So it has a very useful library for working with numerical data. And one of the data structure it uses is the array. Okay, basically it's like a Python list, but there's two main differences that you should note. Firstly, all the elements in NumPy arrays are of same type. So if you remember Python lists, we were able to put in a mixed data type, but as we covered, if you do have mixed data type, then it's probably better to use some other data type. So here, this one is specific for you to use a single data type. And if you put in a multiple data types, for example, integers and floats together, it will try to convert the data types that are not the same into the same one. So for instance, all the integers will be turned into floats, right? The next one is they are multi-dimensional. So we talked about we can nest lists in Python. It's a similar concept, but the structure of NumPy arrays are not really like a nested structure. They are structured like a table extending in 1, 2, or more dimensions. So in this aspect, it's much more easy to interact with a data in different dimensions. You'll understand better when we go apply some operations to NumPy arrays later on. So what is the advantages of arrays? Well, using arrays is much faster than using lists. One reason for this is that data in array is normally laid out sequentially in memory in a block, which can make it very fast to access. So that means NumPy will handle the way that array values are stored in the memory such that they are next to each other. By doing this, accessing the data is much fast compared to when you think about how the lists are stored in the array. Lists are stored in the memory space. Each container will have its own reference, but they're not necessarily be next to each other. Therefore, you still have to go through and find individual references to retrieve the value. So in that sense, it can be quite slow, especially when we're handling a large-sized lists. Okay. So NumPy also makes use of under-the-hood fast libraries for optimization. If you are familiar with the history of Python, many of its modules are actually written in C. And performance-wise, language C is about 10 times faster than Python. and many of the modules for NumPy is written in C, which gets pushed back to the Python to use. So calculations are done in C, majority of it. That's why NumPy can bring you much faster calculations. And finally, Python provides many convenient features for performing numerical calculations with arrays, which we'll cover shortly, so that you don't really have to re-implement some of those features. Right? So let's get started by creating arrays using NumPy. Right? So a very easy way of doing it is creating from using Python lists. So you can create a Python list first and pass it on to a NumPy array constructor as such. So let's get started with that. Here, let's just restart the shell. Restart. So here I have nothing loaded here. Import NumPy. Okay. So if you get an error trying to import NumPy, what you have to do is install NumPy. If you're on a Windows machine, if you open up command prompt, and by default you should get pip installed when you install Python. So if you want to check the version, you go pip-v, and this one is linked to my Python version 3.6. This should match this version here. Then you can go pip install NumPy. Okay, so if you have errors, that's how you will deal with that. Okay, so once we have that, then now we can create those. Array1 equals numpy.array, and then we pass in some numbers, right? 0, 1, 2, 3. Okay, so that doesn't complain anything about it. Array1 equals, it tells me that this is an array which contains values 0, 1 to 3 inside a round bracket. Because it's not a Python list type, it's always going to show us this is an array. Okay, so this is how we will differentiate between Python lists and NumPy arrays. Okay, and because typing in NumPy all the time is quite cumbersome, you can always go import NumPy as NP. So this is shortening the name of NumPy as abbreviation NP. Then whenever we want to call it, instead of calling NumPy, now we can just replace that name with name NP. Okay, then it's going to do the same thing and contain the same item here. Do note that if we do create such as one-dimensional arrays, we call these as vectors, and if we create two-dimensional arrays, they are matrices. Okay, so those are some terms that we will refer to some specific sized arrays in NumPy. Right, so as we mentioned before, NumPy arrays will have the same data type. So let's just create the second one here. So I'm just going to run this as I have some libraries being loaded. Okay, so now we have array1 and array. Oops, I must have overridden it somewhere. Let me just come back to that. All right, let's try again. Run this. Array1, okay, and array2. Okay, so they're all working fine. So basically, if it interprets all the values inside as an integer, then it will show me integer values like here. But if any one of the values are of different type, it has to match it. So in this instance, converting integer values into the float will maintain these float point values. So it will try to convert these guys into float values. So you can see that everything has been added with the point, which represents it's a float value. You can try mixing different data types further, but obviously if it can't convert it, then it's going to contain items. In this instance, what it did was, because it can save all other data types as a string, that's what it converted into a string type. Okay, and it also shows me that this has been changed to a Unicode. Okay, if you want to make sure that the converted type, if you want to check the converted type, you can always check the dtype attribute. So here array1 dot dtype. It's going to show us that this is int 32. Dtype array2 dot dtype is going to be float 64. So you do notice that this is a little bit different. So this one is int 64, float 64. Here is int 32, float 64. The precision has changed. This will depend on your operating system. So many Windows operating system, it might just push it down to integer 32. Whereas if you're using Linux or Mac, it will likely to store as int 64. Okay, but later you'll find that you don't have to use the defined dtype. You can always change it or force it to use a specific dtype to say you want to have better accuracy for the data values that you have. Okay, so two-dimensional arrays, the same thing. What we can do is create a nested lists and then pass it into the array constructor. So matrices. So I have already created matrices and loaded them up. So I can check the content matrix 1. Yeah, matrix 1. Okay, so it contains values 0, 1, 2, and 3, 4, 5 onto the second item. But again, this is still a array type. Matrix 2 is the same thing, but in this instance, it's a 4 by 2 matrix. So I have 4 rows and 2 columns. Do note that NumPy will try to align things nicely for you. If one of the items has much more spacing required than others, it will try to do the right alignment. Okay, so that's creating NumPy arrays. Very straightforward. You can just easily pass in any iterable values, not just the list, but other iterable objects, and it will try to convert it. So creating them is easy. We can access elements, one-dimensional arrays in much the same way as the Python list. So all we have to do is just pass in the index of the value that we were trying to get. Array1 at index 2 is going to give me value 2 because array1 contains 0, 1, 2. Okay, so the index represents the value here. Similar with the matrix. However, the difference here is that before we had a nested square brackets for Python nested lists, right? But here what we do is instead of using nested brackets, we use comma to separate which dimension we are referring to. So the first, which are the rows for this two-dimensional matrix, I can specify 1. And then, so this is to get me the first row item, which is here, 7, 9, and then get me do I have the, oh yeah, sorry, wrong matrix. So get me 3, 4, 5, and then this 2 references the second item starting from 0, so number 5. So this should return me value 5. You do get index out of range errors if you're trying to access the index that is not inside NumPy array. Okay, so that's creation and accessing the data. So now let's have a look at changing array elements. Okay, so similar to lists, we can change elements in an array if we want. Basically, we have, say I don't want 5 there anymore, then I just have equal sign and then say, let's say, oops, sorry, wrong index, 10, then matrix 1 should now contain 10 instead of 5. Okay, so the same idea here, we can try to update rainfall of the value, this equals some value. Okay. Of course, we're still in Python, so some precision error may occur. Okay. I do have that rainfall data here. Okay, but we'll use this in the future as well. Okay. Unlike lists, however, NumPy arrays don't have an append. So if you quickly have a look, actually NumPy np.array has has a few built-in methods, but as you see, there's no specific methods, and you can't find append, right? So there's a limited number of things you could do with NP array, but as you'll find out soon enough, that you don't really have to do those operations that you might need it to do in the lists. Okay, so we can specify multiple indices and use them to modify elements in an array as well. So if I want to convert, say, multiple items in the list as the new value, then I can do that. So now this time we're going to use this data array. So this data array is just one long list which contains some random values. Okay, and what I want to do is data at 0, 3, -1. Do not the double square brackets, because this time I'm not specifying one value, but specifying multiple values of indexes, equals 100. So here, if I now look at data, index 0, which is which was 9 point something, has now changed to 100. Index 3, 0, 1, 2, 3, the 11.458 has now changed to 100. And -1, which is the last item, also has changed to value 100. Okay, so this way you can update multiple values at the same time rather than doing one at a time. Okay, so remember double square brackets because we are not specifying one single number, but we have multiple numbers. So instead of just writing to those positions, we could also specify that, for instance, they should all have 50 added to them. So this is trying to modify not to a new value, but by adding some specific value on top of the existing ones. So let's reset our data array. Okay. And so what we need to do is do something as similar before, but what we're going to do is now use plus equal sign. So what that does is it's going to add on the value of the existing one and with the new value that we specify here. So if we do that, now we check the data. Previously we had 9.3, so now it's 59.3. And other specified locations all have been added by value 50. So you don't have to renew the value. You can always modify existing values using some additions. So as you can imagine, not just the plus, you can use some other symbols like minus or multiplications or division. All right, so slicing list is to get a subset view of the array that we have. And this is similar to Python lists, but as we handle multiple dimensional arrays, this becomes much more easier to use. So for example, array 1, we can do as same. Array 1 is that one. So array 1, we can slice it 0 to 2. So starting from 0 up to index 2, but not including. This is going to give us 0, 1. Okay. And also, same idea, array 1, index from index 1 up to the last item. We can do this. A similar idea up to the last, but not including, would be -1. And if I want to slice the whole thing, I just use column. So this is essentially exactly the same as using a one-dimensional Python list. Okay, so no changes there. Okay, so the actual handy part comes when you're trying to slice multi-dimensional arrays in NumPy. So for example, the following syntax let us extract two rows of a two-dimensional array. So here, let's create, what did I name this array to? So we'll use matrix 1, right? So matrix 1 is our multi-dimensional array. And what we can do is matrix 1 at 1. So this specifies that select the row 1, so our second row. And from that row, I want to select all the items inside. Okay, so by specifying comma will separate out the dimensions, and in each field separated by comma, this is where you specify how the arrays are sliced. Okay, so if we do that, then this is going to return us a one-dimensional array because we only picked one value and return the whole row. So of course we can slice that even further. For example, from first item to the last, well, index 1 item to the last. So this is going to give us 4 and 5. Okay. So after the bracket, we specify the index. This is for the row selection, and then specify, in this instance, a colon to retrieve the whole array of the row, and you can change these. So you'll probably be wondering, maybe I can, instead of specifying one row, we can specify multiple rows, and that is absolutely correct. So let's have a look at this. So what this allows us to do is, rather than extracting only one dimension from multi-dimensional arrays, we can extract multi-dimensional arrays from a larger multi-dimensional array. So what we want to do is here, let's retrieve from this matrix. We're still using matrix 1. I want all the rows. That's what this specifies. Okay, and I want columns 1 and 2, so we can specify 1, 2, 3. Okay, so for every row I want columns 1 and 2, but not including the other columns. So if I do that, this returns me 1, 2, and 4, 5. So that means I retrieved all the rows that I want, but only columns 1 and 2, not including 3. Okay, so that's why I retrieved 1, 2, and 4, 5. So this way I can retrieve multi-dimensional subcolumns and rows from a larger dimensional ones. Okay, so this one is probably really difficult to do in Python, where you probably have to implement like some loops and some new arrays to do so. Okay, so we're going to briefly talk about slices as views. So you may have remember about aliasing problem before. When we create slices, what happens is that the reference may be pointing at the same dataset points. If that does happen, then if you update some of those slices, the original data can also be affected. So here's an example of using rainfall. Okay, let's just run this again to clear this. So we have this rainfall data, and what we want is some small 2 weekdays, which extracts all the rows, but only columns 2 to 4, so only columns indexed at 2 and 3. So this one, 2 weekdays, if we look at it, it retrieved us 2 and 3, so 0, 1, 2, and 3. So these 2 columns, 1.6, 4.8, 0, 0.2, and so forth, right? So we got it correct. But what we can do with the slices, we can update the values as well. So 2 weekdays, say 0, 0, this is our first row, well, 0th row, 0th column. So that's 1.6 what we have. Just double check, right? And then we're going to update this to 9.9. And what happens is I check 2 weeks, then I have updated this point to 9.9. That's fine, but what happened with our rainfall is that because this slice it's chopped from the original rainfall, this 2 weekdays variable is actually pointing at the same values. Therefore, it also has altered the original data. So what it does is Python tries to provide us with a view of the original array. And if we change an element in the slice, it's changed in the original array as well. This happens because both variables are pointing to the same location of those data. So what we want to do is create slices that are not pointing to the same values. Rather, we want to create copies of those, right? So Python can only give us a view when we've asked for a continuous set of cells. If we ask for non-continuous columns, we'll get a copy of the data. So that's what we're trying to do here. So here it was column, and then we had a 2 to 3, but in 2 to 4 instead, I'm going to ask for 1 and 3. Okay, so let's rerun this, reload. Okay, rainfall. Okay, and then 2 other weekdays equals rainfall column 1, 3. Okay. 2 other weekdays contains these values as we suspect, and what we're going to do is 2 other weekdays 0, 0 is going to be 7.7. Okay, so now we check the content of the 2 other weekdays, and it did update from 0 to 7.7. And if we look at the rainfall, it did not have a value 7.7. This is because this is a non-continuous values. Therefore, what it did was create a copy of the new data and then gave it a new reference to those. Okay, so remember at the very beginning we mentioned that array values are stored sequentially in the memory space, and if we divide this up, it can no longer have those values saved as sequence. Therefore, it's going to create a new array to store these values in the sequence. Okay, so we have seen that by specifying columns, not a continuous one, we can avoid the aliasing problem because it's going to create a copy for us. So what we can do is create 2 other weekdays equals rainfall column. Previous example was, what was it? 2 to 4. So that's essentially looking at columns 2 and 3. And by doing this, we can avoid the aliasing problem because although for us we know that this is a continuous columns, Python doesn't know that this is necessarily continuous in the memory space. So what it does is create a new copy set for us. So 2 other days, 0, 0 equals, check the value 1.6, say 9.9. So now we have updated it. So 2 other days has changed the values up here. And what we can do is rainfall check. And as you can see that it was supposed to be this value that supposedly updated if it had the same reference. But in this case, it didn't update to 9.9 because by doing this, by specifying specific columns, we can avoid the aliasing problem by creating a new dataset points. Okay? And to really avoid this problem, what we can do is use the copy function that NumPy arrays provide. So instead of doing this confusing stuff, and that's going to be quite difficult to implement, what we have is we have rainfall, and what we do is 2 weekdays equals np.copy. So we have a copy function, rainfall data 2 to 4. So this one was the aliasing problem one, but by doing the np.copy, it's going to create us a new NumPy array, and we can quickly change this 0, 0 equals 9.9. Okay, and then we check the 2 weekdays. It has updated fine, but rainfalls has not been updated with value 9.9. Okay, so this is more better way of getting a new copy out of multiple dimensional matrices rather than trying to implement it like this. Okay, so using functions, we will cover more about in the next video, I think. Yeah, we'll cover that over there. So we'll stay tuned for that. All right, so now we have seen how to slice the matrices and avoid aliasing problem by specifying columns or using the copy method associated with NP arrays. The next thing we can do is apply different operations in arrays. So these operations are actually quite unique and much better than Python lists because it allows us to perform for multiple numbers at one go. So here's an example of arrays 1 and 2. Do I have them? I think I defined them up here, arrays 1 and 2, but we're using array 2 differently. So let's redefine that. Array 1. So here I have array 1 and array 2 is 4, 5, 6, 7. 4, 5, 6, 7. Okay, so we're ready to go. So we have now array 1 and 2. So what we can do is, because these arrays are same size, we are able to add them together. So array 1 plus array 2. Okay, and what it does is element-wise operation. So element of each array are matched up into pairs, and then operation is performed on the pair elements. So 0 plus 4, 1 plus 5, and so forth. This gives us 4, 6, 8, 10. Okay, and we can also do subtractions. Array 2 minus array 1. Okay, and this one is going to give us 4, 4, 4, 4. Okay. If the sizes don't match up, then it's going to give us an error. So just have a quick look, 4, 5, run it, and then do array 2 minus array 1. Then it's going to complain us that it can't do these operations together because the shapes of these two arrays are of different size, 4 and 2. Okay. So do remember that if you do array and array operations, the size must match together. Okay. Instead, if you want to apply the same operation using a single value to all items in an array, you can use a scalar mode, scalar operation. So we can perform arithmetic operations which takes only one array and one scalar. So here we have array 1, and what we want to do is array 1 plus 10. I want to add 10 to all the items in array 1. So this is going to return me 10, 11, 12, and 13. Okay, so not only pluses, but we can do multiplications. That's fine, as well as subtractions, and the order can also be other way. Okay, so here we have 7 minus, 7 minus array 1. This is going to do 7 minus each numbers inside the array. And we can do array 1 to the power of 2 to find out the squared values of each items. So this one, you can easily see that, for example, if we were using Python lists, if we wanted to do squaring, we have to go through each value. But here you don't have to. You just have to use the scalar operation. So this concludes this video. Ooh, 35 minutes or so. Yeah, quite long. But these covers all of the basic operations and how the data is structured, allowing you to do a much more advanced, well, more quick way of doing some operations such as shown here. All right. So that concludes this video. I'll see you in the next video. What are we doing next video? NumPy functions. All right, bye.